In this video I'm looking at the solution to question 4 from the January 2011 Edexcel D1 paper. The topic of the question is matchings. In the question we're told that there are 6 workers who are to be allocated 6 tasks, and the figure 3 shows the possible allocations of the workers, and an initial matching is shown in figure 4. In part A, we're asked to write down the technical name given to this type of diagram, and then in part B to use the maximum matchings algorithm once to find an improved matching. And we're asked to state the alternating path we use and our improved matching that we find. Then in the final part of the question, we're told that Anthony now agrees to do an extra task, task 6, and starting with our improved matchings, we're to use the maximum matching algorithm to obtain a complete matching. So we state the alternating path and also the complete matching that we managed to find. Well, part A of the question says, first of all, write down the technical name for the graph that we've got in figure 3. Well, this is because it's got 2 sets, so this is what's called a bipartite graph. By coming from the fact that it's just got 2 sets of points. In the next part of the question, we're asked to use the maximum matchings algorithm. So this means that we've got to match up a point on the left hand side from A to B, D, J, K and M, they're one of the people, to a point on the right hand side which are unmatched. So we could either D going to 1 and 4 or J going to 1 and 4. Now there are many different ways of doing this, but one way, if we look at the diagram on the left, we can see if we start at start at J, we can go to 3. So let's mark that in on our diagram as we go. From J, we can go to 3. But that would mean that we can't have B doing 3, but B, looking at our diagram, could do 1. So we've then achieved our aim of connecting with an alternating path J to 1. So our alternating path was from J to 3, which wasn't matched at the time, to B that was matched, to 1. And then we changed the state of that to give us J matched with 3 and B matched with 1. So our total matching now is A with 2, B with 1, D is unmatched, J with 3, K with 6 and M with 5. So now there are many different ways that could have been achieved, or at least a matching better than we had initially could be achieved. So don't be surprised if the way that you manage to do it is different to the one that I've done here. But the method mark and an A mark given for the alternating path, and finally for listing the matching that we have at this stage, an A mark. So you have 3 marks for that part of the question, and there was a B mark for stating the bipartite graph in part A of the question. The next part of the question says, starting from this situation, then see if we can get a complete matching by matching or finding an alternating path which goes from D this time to 4. So we need to start at D and go to 4. Well, again, there are different choices, but one way, I'm going to just look at our path here from D, we could first of all go to 2 and then to A, which is now joined to 6. So this is the new line, which I'll just mark in here. We've got a new line going from A to 6. And then from 6, well, that's done by K at the moment, and K would then go to 4. So you're writing that down before I actually mark it onto the new diagram. It was from D to 2, which was matched with A, then to 6, which was matched with K, but then to 4. And then changing the state of that so that D is now matched with 2, A with 6, and K with 4. So we've increased the matchings by 1 there. Let's put that onto the diagram as well. So from D to 2, not A, but A is now going to be doing 6. So K can't do 6, but K will do 4. So our matching is now as follows. A is 6, B is 1, D is 2, J is 3, K is 4, and M is 5. Again, there are different ways of doing that. So, you know, it's not a unique solution in this case. The marking for this was, again, an M1A1 for the alternating path and a final A mark for the complete matching at the end. And that's the solution to that question. You can find solutions to other questions at www.furthermaths.org.uk.